Okay, so in this video, I will be covering APCS FRQ 2019 question number 3. The problem starts off with many encoded strings contain delimiters. A delimiter is a non-empty string that acts as a boundary between different parts of a larger string. The delimiters involved in this question occur in pairs that must be balanced, with each pair having an open and closed delimiter. There will be only one type of delimiter for each string. The following are examples of delimiters. So in conventional math, we see the classic delimiters, which are parentheses, and in this expression, it's completely valid because we have an open and then a closed. These balance out to contain the x plus y part. In this one, we do not have a balanced expression because the y may be balanced, but the entire expression is not, because there needs to be a closed delimiter at the end to correspond with this one. Alright, example 2 also shows different types of delimiters in different programming languages like HTML. The B here is called a tag, and then we also have a /b as a close tag, and the text in between is bounded by the open and close tag, but in the second example this isn't true because the close tag is invalid. Right, so this is the class that the question provides us. The open and closed delimiter are already given to us in a pre-existing constructor that creates the instance of the delimiters class. So we don't have to worry about how we get this. All we need to know is these two values or two objects are givens to us in this problem. And to see a quick preview of part A, we're going to be returning an array list of delimiters from the array tokens as described in part A. So this is the method signature, and the parameter we take in is a string array called tokens. Okay, so the directions: a string contains text and possibly delimiters, has been split into tokens and stored in a string array tokens. Each token is either an open delimiter, a closed delimiter, or a substring that is not a delimiter. You will write a method getDelimiterList, which returns an array list containing all of the open and closed delimiters found in tokens in their original order. The following examples show the contents of an array list returned by getDelimiterList for different open and closed delimiters and different tokens arrays. So in this example, the object contains an open and closed delimiter of the conventional parentheses, open parentheses and closed parentheses, and the tokens, which are the parameters or what's given to us, are the parentheses, this expression here, close parentheses, another expression. So all we have to do is return an array list of only the delimiters, which means we ignore the x plus y and the multiply times 5, and we're left with this array list here. Same thing for example 2, we ignore everything that is not this open tag or close tag, so we're crossing out the y and zz, and we're left with everything else. Okay, so to start the part A off, we're going to write the method signature, which is returning a string array list, and it takes in an array of strings called tokens, and we're going to initialize an empty list of delimiters, which we will be filling. Then we're going to write a for each loop, which accesses an individual token of the tokens array. This is another way to go and loop through an array without worrying about the index. It just directly gets the value of the element, which is called a for each loop, and it checks if each individual token is equal to the open delimiter, or, which is this comparator over here, or the closed delimiter. So it has to, if it's equal to either or, it adds the token, and then once it's done checking through this loop, it returns the list that it results with. Alright, part B is complicated because APCS FRQ is always increasing complexity as you go through the problem. So part B says write the method is balanced, which returns true when the delimiters are balanced and returns false otherwise. The delimiters are balanced when both of the following conditions are satisfied, otherwise they're not balanced. So in this problem, they're kind of giving the conditions we should be checking in the method, which is really good because this is probably the hardest part we would have to do if we're not given these conditions, but luckily we are. So when traversing the array list from the first element to the last element, there's no point at where there are more closed delimiters than open delimiters at or before that point. And also the total number of open delimiters is equal to the total number of closed delimiters. So those are our two conditions. So in this example here, we're going to be using a sub open tag and a /sub close tag. And we're basically going to look at the logic behind the ideal is balanced method if we did write it correctly. So let's say we're given this string here and we have to see if it's balanced. We're first going to look at this first delimiter, then the second one. And example 2 shows which law is being violated. And in this case, condition 1 is being violated because when we're looping through the string from left to right, we see a close tag misplaced. So that's why this problem would be incorrect and the method would return false. Because it says after examining all the tokens, there are not equal number of open and closed delimiters. Okay, so to start the problem off, we'll be writing the method signature is balanced, which returns a boolean and takes in an array list of delimiters, only delimiters. And we're going to start off with saying that the number of open delimiters that we see so far, and the same thing with the closed delimiters, is both 0 because we haven't started looping through the array list. Then we can write the loop that we use to go through the array list, and this is a for each loop accessing the individual element without the index of the delimiters list. And then we're going to be checking two conditions. So if the individual delimiter element is equal to the open delimiter, we're going to increment the number of open delimiters we see. And same thing with closed delimiters. If the individual element of delimiters list that we see is equal to the closed delimiter, we're going to be incrementing the number of closed delimiters we see. Basically, we're saying whenever we see an open delimiter in this list, we're going to increase our count of that delimiter type. But then we need our most important condition, which satisfies condition 1. If the number of closed delimiters that we see so far is greater than the number of open delimiters that we see so far, then return false immediately. So the reason why I'm saying so far is because we're still in this loop and we're not yet breaking through this loop, and therefore we kind of have to keep track of what we're seeing so far. And in this case, if we see too many closed delimiters, and if that exceeds the number of open delimiters, we immediately know this can't be balanced due to condition 1. But then condition 2 also comes in. Return num open equals num closed, which is basically saying return true or false depending on if the number of open delimiters equals the number of closed delimiters that we saw in the entire array list, which satisfies condition 2. And the reason why we're saying return false here is that if we see that the number of closed delimiters is greater than the number of open, there's no reason to keep traversing through the loop or keep traversing through the list. And we basically know that this can't be balanced anyway. So to save computer runtime and to increase our efficiency, we're just going to break out of the loop by putting our return statement over here. And then this would kind of be like a worst case scenario of condition 2, which states that if they're not equal, this can't be balanced. Otherwise, if we do see the same number of open and closed delimiters, then this is true. Only if we're able to actually reach the end of this loop. Thanks for watching.